Good morning to all the participants and Umang sir.
Yeah, good morning, sir.
Good morning, sir. Today is the fourth day of Machine Learning and Pattern Recognition program, which is sponsored by AICTE-ISTE. This program, in this program, we called Mr. Umang Kejeriwal, sir. Okay, he is director of Apptronix Technologies. So I hand over the session to Mr. Umang Kejeriwal, sir. So please continue, sir. Continue the session, sir.
Okay, thank you so much, sir. Okay, good morning, all participants. So let's start the session now. I'll share my screen. Okay, so I hope you can see my screen. Yeah. So today we have to learn about the artificial neural network. Okay. What is artificial neural network? How does it work? And we will be doing one practical also based on this. So this is our today's topic. So, okay. So basically, this neural network is a part of deep learning. Spelling is wrong. Okay, it's a part of deep learning. Okay, now this deep learning basically consists of three things. First of all, it is divided into three parts. That is ANN, general I am saying, CNN and RNN. So here ANN stands for artificial neural network. Okay. CNN stands for convolutional neural network. Full screen. Is my slide not coming on full screen?
I think it is okay, sir. But in case if participants say, we check it, sir.
Okay, okay. All of you, please tell me on the chat.
Mr. Ajay, is it okay? Yeah.
Okay.
No problem.
Okay, thank you. Okay.
Thank you.
Okay, well. Okay, so artificial neural network, convolutional neural network, and this stands for recurrent neural network. Now, what do we use this? See, basically, ANN, I will tell you the working of this ANN. So basically, this ANN we use generally for the text data set. A data set in the form of a text. Okay. And we can use it for image also, but it gives you better result in the case of text data set. If I talk about CNN, we generally use it for images. If our data is in the form of images, but we can also apply it for text. The same thing, it works better for image. Okay. Okay, sir. Okay, fine. No problem. So these two here, this neural network, this artificial neural network and convolutional neural network, here totally we have a concept of a neural network. You must be knowing about the neural system that is present in our brain, right? So this is basically based on the brain concept, the concept of the neural system that is present in our brain. Here basically we create the replica of the human brain. How does the as if our human brain work, we create a simple kind of a system in this ANN and CNN. But in CNN there will be some more techniques. So that thing CNN will be discussing tomorrow, and today we will be discussing ANN. Okay. And now this RNN, here basically we have a concept of short-term memory. Like in the brain, there is one part of short-term and long short-term memory. There is a short-term memory, now, like you must have seen that Gajni movie. He forgot, short-time memory loss is there. So there was a problem in that part. That's why he was having that problem. He was having a short-term memory loss. Similarly, as a normal person, if I remember something today, maybe after 1 week, I will forget that thing. So that concept is there in the RNN. So we generally use RNN for the recommendation system, for the text classification, for the time series analysis. For all this purpose, we use the RNN. Okay. So today I'm going to discuss completely about ANN, that what is ANN, how does it work, and then after explaining all these things, I will explain you in a practical way also. Okay, so let's start this ANN. So in this ANN, what we are going to cover, first of all, we are going to cover about the neurons, and we also call this as a perceptrons. Secondly, we will discuss about the activation functions, which is also known as transfer function. Okay. Then the third one is the cost function, which is also known as error or loss function. Okay. Then we have a gradient descent. This is the optimization technique. And the last one is the back propagation. It's back propagation. Okay. So these all things, these 5 things we are going to discuss in this slide. Now, what is neurons? It's a very important part of brain through which the signals are transmitted. So it is a very important part of it that carries the signal from one place to another. It's a very important part of brain. And we also call the neurons as perceptron. Then artificial neural network is based on, this is neural biological system. I will change it. This is neural biological system. The neural biological system that is present in our brain, it is totally based on that concept. Okay. Then it is a software-based approach to replicate the biological neurons that I already told, that here we are actually replicating the neurons through which we will be doing the operations of the brain as if the brain work. Now let's discuss something about biological neurons. You must have studied in your junior classes in class 9th or 10th, I guess, and maybe you remember about this biological neuron. So this is your biological neuron, and majorly we have these 5 things inside this biological neuron. The first one is the dendrite. The role of dendrite. Can anybody tell me the role of dendrite? Anybody? What is the role of dendrites? Anybody, if you know? Stimulus giving. Okay. Okay. Anybody else? Receiving. Okay. In simple words, we can say that it receives the input from the other neuron. Yeah, impulse also. Receives the input from the other neuron, and after receiving the input, it is sent to the cell nucleus that is present inside the cell body. Now, what this nucleus do? Nucleus will process that input. That according to that input, what will be the desired output? What will be the response according to that input? So that response or that output is transferred or is traveled through axon, and it comes to axon terminal, and through axon terminal it is given to the another neuron. So here will be the other neuron which will be connected. So all the neurons are connected with each other, and one by one the signals are transmitted from one neuron to the other neuron. And this is how the biological neuron work. Right? So now we will discuss about how your artificial neural network work, how this artificial neurons work. So I'm right now, whatever the working I'm going to discuss, this is the working of a single neuron. Okay. So this is a block diagram, say a simple block diagram to explain the working of artificial neuron. Now, before coming to this block diagram, I'll explain you in the whiteboard so that you will get it more clear. I'll discuss a simple example to explain you this. See this artificial neural network basically is of two types. The first one, we call this as simple neural network. Let's say that simple neural network. And secondly, we call this as multi-layer neural network. Now, what's the difference here? In simple neural network, we use this for solving the very simple statement, very simple problem statement. Just hold up. Okay. So to solve a very simple problem statement, but in case of complex problem statement, we use the multi-layer neural network. Now, how it is basically there? So basically in simple neural network, there is only two layers. The first layer is called input layer, and the second layer is called output layer. So input is directly connected to the output layer. That's all. In multi-neural network, there are more than two layers. At least there will be three layers. It can be more than three also. So this is called input. This is called output, and this is called hidden. So there can be more than one hidden layer also. It depends on the problem statement. If it is more complex, you may have to take more than one hidden layer. Okay, so basically the first layer is always called input. The last layer is always called output. And in between, whatever the layer you see, that will be the hidden layer. Okay, so right now I am explaining this neural network by taking the example of this multi-layer neural network. Okay, so let's discuss this example and explain you this multi-layer neural network or neural network. So let us suppose that we have an image here. Okay, now on this image, there is a picture of a cat. Just suppose there is a picture of a cat. Now, the samples that we are having, that sample contains either cat image or dog image. Only these two images are there. That means there are only two classes. We can call this cat as 0 and dog as 1. Okay, cat as 0 and dog as 1. So you can basically, we cannot take the name. We have to convert this into binary form, into a number, into numeric data. So we are considering that the cat is 0 and dog is 1. So basically, the final output, like what I want to do is, I want to predict that what is the, who is the animal in this picture? Is it a cat or is it a dog? So the final output will be what? Either 0 or 1. So in this case, what output I am expecting? 0, right? So this is what I want to do. So as we all know that in our brain, how does it work? We just see the image And after, just tell me all of you, can anybody explain me on mic that how basically we see that, we say that this is a cat image? What things basically goes in our mind and we say that this is cat? How? Anybody? Anybody? Features. Okay.
Sticks.
Yeah, please repeat. Actually, your voice was breaking. Repeat.
Look at the shape, then identify,
Okay.
and then also
Ah.
concentrate on the characteristics of object.
Yes. Can I say that basically in our mind there is a picture of a cat, right? And we basically compare this image with that picture. Can we say that? Yeah. So basically what we do, we have a picture of a cat in our mind and we simply compare this picture with that. If that comparison is done, we can say that this is a cat. The comparison is not done, then we can say that it is not a cat. The same thing we are going to implement here. Same kind of a thing. So basically, if a new child is born, when he becomes elder and elder, then how do you teach a child? You show them some pictures, right? They learn by visualizing the things, that this is a cat, this is a dog. Now you say them, you teach them every day, and at one time, there is one time when that child will become very accurate. He can give any correct answer, right? Same thing, as a child learn, we have to train the machine in the same way. So how it will work? So if I consider this example multi-layer, we will have 3 layers, right? So let us suppose that this is my input layer, and in this one I am assuming that there are 2 neurons. 2 neurons. When I will explain the practical, then I'll tell you basically how this number of neurons are basically divided. It's not 2, it's very high. It can be 1,000, it can be 10,000 also. It can be 15, it can be 20, it can be 16. Depends on you, I'll tell you later on. But right now, I am assuming that there are total 2 neurons. 2 neurons means I have divided this cat image into 2 types. I break this data into 2 neurons. Just understand this, okay? So just suppose this is my neuron 1, this is my neuron 2. Now, the next layer will be the hidden layer. So I'm assuming that on hidden layer, there are 3 neurons. I'm assuming that there are 3 neurons. Okay. Then the last one is the output layer. Output layer is very important. Just tell me, all of you, what is the final output we will get after the prediction? Tell me. How many outputs basically we can say? How many outputs we are getting? No, we have the 2 options, right? We have 2 options. But finally, we will be getting only one output, na? Either 0 or 1. Either, it's either, right? So if the output is either, there will be only 1 neuron here, only 1 neuron. If the output is either. And let's suppose if there is a scenario where I want the probability that 70% it looks like cat and 30% it's look like dog. So in this case, how many output we are getting? 2, na? 70% and 30%. So there will be 2 neurons in that case. Am I clear? So it depends on you what kind of output you are expecting. If you are expecting either cat or dog, you have to take one neuron. And if you are expecting a probability, you have to take two neurons. Okay. Now these neurons are connected to each other like this. This neuron will be connected to all these three neurons in the next layer. And this neuron will also be connected to all these three neurons on the next layer. Same thing is for here also. So this is how your neurons are connected. And this makes the neural network. This is a complete neural network. Okay. Now, how does this work? How it will predict the output? Now I'm going to explain you that. Now, when these neurons are connected to each other, they are having some weight value. Let's suppose this is weight 1. I'm talking about the connection of these two. Okay. This is weight 2. This is weight 3. This is weight 4. This is weight 5. And this is weight 6. So basically, initially we give any random value of weight. Any random value we give initially. But later on, after applying some kind of optimization technique, we fix the value of weight. So that thing I'll explain you after some time. So right now, just assume that we have taken some random value of weight, any random value initially. Okay. Now, what will be the output of this neuron? That means after doing the operation on this first input layer, what will be the output of this? So if I name this as A, let's suppose, okay, A, let's suppose B, and let's suppose C. So right now I am talking about A. That for A, what will be the output? So A is a single neuron. So the mathematical model for a neuron, the mathematical formula, or we can say the model for a neuron is summation of x equal to, or we can say summation of I equal to 0 to n xn into wn, sorry, xi into wi, xi into wi plus bias, where x is your input and wi is your weight. This is for a single neuron, not for every neuron. Now, let me solve this so you'll get it clear. Now I'm talking about A. Just tell me on A neuron, which two weights or three weights are there. Just tell me the name of the weights which is connected to neuron A. Tell me. Just look to my diagram and tell me. On A, W1, W2, W3. No. See, on A we have W1. Yes, Subhangi, Swapnil, correct. W1. And here you can see this is, what is this line? This line. This is W4. So W1 and W4 are connected. Okay. Now, what is the input of W1? N1. So we write here N1 into W1 plus N2 into W4. Tell me, is this thing clear? Yeah, it's okay. It's okay. Clear? So this is this part. We have solved this part. Okay. Now bias. What is this bias? Bias is a very small value. It's a very small value. You can take any small value, like suppose 0.02. It's your choice. You can take any small value and it's fixed. So it's a very small value which help us to keep the neuron active. To help us to keep the neuron active every time. Am I clear? Now, when it will be active, just suppose that the value of N1 and N2 is 0. So tell me, if it is 0 and if there is no bias, what will be the output of this one? 0 only. So if the output of this neuron is 0, then your neuron will become inactive. Inactive neuron should not be there in a model. Your model will not perform well. Sometimes we say na, dimag ki batti jalao aur kaam karo. That dimag ki batti jalao, we say in that sense only. That neuron ready nahi hai aapka. Neuron is not ready. It is inactive. So basically, it should be active every time so that whenever I have to take a signal, I can easily take it. So that's why we add a bias value so that this 0 will not be 0, it will be 0.02. So am I clear, all of you? Tell me. So this is how this calculation will be done for all the three neurons, A, B, and C. And let's suppose that after solving these three neurons, we are getting the value of A as 2, B as 5, and C as 10. Just suppose. After solving this equation, I am getting this value. I'm assuming this just. So now after this all calculation, what is the next step? This is not the final value. This is not the final value of neuron. No. The final value of neuron will be the this one, fx. And we can say that we have to pass this neuron to the activation function. To pass this neuron to the activation function. Now, what is this activation function? Activation function is just like any mathematical equation which takes your output near to your desired output. Near to your desired output. Just tell me what output we are expecting. What output we are expecting? Yeah. You're expecting what? 0 and 1 only, na? Tell me. 0, no, don't tell cat and dog, 0 or 1, right? So tell me, is it 0 or 1? Is this 2, 5, 10, 0 and 1? No. So we have to convert to 0 and 1. We have to convert this value to 0 or 1. So how to convert this? We have to use any mathematical equation which can convert into 0, 1 and 1, 1. So do anybody know the activation function? Any mathematical equation that can convert this value between 0 to 1? Anybody? Any equation of any mathematical equation that can convert this value between 0 to 1? Tell me. I think no one knows. Okay, have you heard about this function? Yeah, okay, Kakas have told. Sigmoid function. The equation is what? Fx is equal to, Fx equal to 1 divided by 1 plus e to the power minus x. This is the sigmoid function. So basically, if I pass here 1 plus e to the power minus 2, it will be somewhat between 0 to 1. Between 0 to 1. Okay. So whatever the value, let's suppose that after passing this to sigmoid, I am getting the value of A is 0.5, B is suppose 0.2, 0.5, and C is suppose 0.9. Just suppose. Then this value we will be taking in the neuron. Here, this value. So this will be 0.2, 0.5, 0.9. After this, the same thing will be applied for this neuron also. What will be the formula for this neuron? Suppose this is W7, W8, W9. So the formula will be 0.2 into W7 plus 0.5 into W8 plus 0.9 into W9. Suppose after solving this equation, I got the value as 5. Just suppose 5 or 6. Just suppose. Then after again using the same sigmoid function, suppose after passing the sigmoid function, I am getting the value as 0.6. We can use the same function also. So 0.6. So now this 0.6, what we will do here? If the value is greater than 0.5, we will consider that as 1. And if it is less than 0.5, we will consider that as 0. So tell me what we will consider in this case, 1 or 0? 1. That means it has predicted that image as 1. 1 means dog. It has predicted it as dog. So this is the first thing. So tell me all of you, is this thing clear? Tell me. And if you have still any doubt, your doubt will be cleared during the practical, because all these things we are going to implement, not image one, because image will be more complex to do it right now. Image we will be doing tomorrow in the CNN, but today we will be doing with the same concept, the same, all the formulas we will be applying in the practical. Then you will be understanding this in more details. Clear? Okay. Now we got the dog. Now we have to make it correct. It's not wrong, but it's not correct. So basically what we do now, now the concept of cost function and the gradient descent will come. What we will do, we got the output as 0.6. So now we will calculate the error. So what will be the error? Actual minus predicted. What is my actual output? 0. Predicted output 0.6. So this will be how much? Minus 0.6. So this will be my error. So we have to solve this error. We have to make it near to 0. So to optimize this error, we use the technique that is known as gradient descent optimization. Gradient descent optimization and back propagation. These two techniques are used to optimize your error. So what we do in this case, we basically change all the previous value of weight to a new weight. That means we have taken 9 weights, right? All the 9 weights value will be changed again and again till you get the least error. You have to change the value of weight again and again. That means you have to adjust the value of weight till you get the least error. The adjustment should be done. So the formula for that is new weight equal to old weight plus alpha into dy by dx, where alpha is equal to learning rate. Learning rate is the rate at which you are changing the value of weight. So basically, in the case of learning rate, we keep the value as error. We place the value as error because it should be a very small value. Clear? Then y is your activation function that you are using. That means you have to take the derivative of activation function. Like we are using sigmoid, so we have to take the derivative of sigmoid in terms of x, where x is your predicted output. Predicted output. Sorry. Okay. So after solving this equation, the new weight you will be getting, you will be applying the new weight, again reapplying all the process. Then if you again get the error, so again you have to apply the same thing. You have to apply again and again till you get the least error. So this step in this formula, this part is known as gradient descent, and this complete part is known as back propagation, because here it goes back to the layers and change the value of weight. Keep it as a new value. Am I clear, all of you? So this is a complete working of our artificial neural network. So I hope it is pretty clear, all of you. How does this work? Tell me. We will do the practical, then it will be more clear if you are still having some small doubt. Tell me, all of you. Yeah, clear. Okay, fine. Now we'll do the practical. So now let me tell you what is the problem statement we are going to discuss now. Just a second. So the problem statement that we are going to discuss now is, we will take 3 inputs, x1, x2, x3, and there will be one output, y. The input will be in the form of 0 and 1. Okay. So let's take any random samples. 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1. Let's suppose I have taken these 4 samples. Any random 4 samples I have taken. And the output of this sample is, this is also random I have taken. So this is my 3 inputs. I have taken 3 inputs and 1 output. So the output of this one is 0. The output of this one is 1. The output of this one is 1. The output of this one is 0. So we are going to apply the artificial neural network to get this output for these inputs. So this is the problem statement that we are going to discuss now. And all these formulas that I explained just now, we will be applying every formula right now. So am I clear, all of you? Is the problem statement clear? Okay, so let's do it now. So I'll open the Google Colab. Let's take a new file. Okay, so I'll give the file name as SSBT 24th December simple neural network from scratch. Okay. Scratch means without any TensorFlow library. We are going to use without library. We will use all the formulas that I explained. Okay. Now, first of all, I will create the data set that we have to use. So this is the data set that we are creating. Okay. So I'll import the NumPy library to create. I will create in the form of array. I'm sharing the link of this file so that you can get my code. Okay. So x is equal to, x is my input, np.array. I'm getting a 2D array. So I'll write here 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1. Okay. The output I'm expecting is 0, 0, 1, 1. That means the output of this is 0. This one is 0. This one is 1. This one is 1. So if I print x and if I print y, this is your x input and this is a y output. All of you please create this, then I will move further. Please do it. After completing, please tell me. Done? I hope you have done. Please tell me. No one is responding, so I'm thinking that you have done. Okay. Now, first of all, we will assign a random weight value. I told you that initially we assign a random weight. So tell me how many weights we will be assigning here. Anybody? How many weights will be required? 2, 3, 4, 5, 6. How many? How many weights will be required? Yeah. No one is saying anything. We will take 3 weight because there are 3 input x1, x2, x3. Right here 3, 1. I'm generating a 3 cross 1 array, and that is a random array between 0 to 1. It will generate any number between 0 to 1. Now this is a random weight, so every time it will change the value. See, every time it is changing. So to fix this randomness so that it should not change every time, what I will do is I will write here np dot random dot seed, and here you will pass any numeric value, any you can pass. Let's suppose if I am passing 10, so I'm getting this weight value. So now every time if you run, the value will be same, it will not change. So here we have fixed the random value. So we have defined 3 random weights which we will be applying to our neural network. Okay. Now, as this is a very simple problem statement, so here we will not take 3 layers, we will take only 2 layers. The first layer is already created, that is the input layer. So this is only my input layer. So basically right now what we have done, I'll tell you. Actually what we are going to create right now. If I take the example of my first sample here. So this is my neuron 0, 1, 0. This is my first neuron. So this is my input layer. And the output will be either 0 or 1. So this is what we are going to create now. This is the neural network we are going to create now. So if you see, the weight of first one is 0.77. The weight of second one is 0.02. And the weight of third one is 0.633. So the output of this one will be 0.77 into 0 plus 1 into 0.02 plus 0 into 0.63. So it will be 0.02 only. So we have to pass this with activation function. So we will use sigmoid. So 1 divided by 1 plus e to the power minus 0.02. So whatever the value will be, we will be getting there. So tell me, is it clear what we are going to do now? The same thing will be done for all the 4 samples. So if we do the dot multiplication of 2 matrix, can we say that we are doing this operation only? Yeah. Suppose this is my matrix. First of all, tell me, I think I am audible now because no one is responding. So I am only speaking only. So please tell me, at least respond something, yes or no. Okay. This is my input. And this is the weight I have created, 0.77, 0.02, 0.63. So if you do the dot multiplication of these 2 matrix, what will be the output of these? This 0 will be multiplied with this, then 1 will be multiplied with this, and 0 will be multiplied with this, right? So we will get here 0.02. Then in this case, what you will get? 0.77 plus 0.63. How much? 0. I think 1.40, right? So if I do the dot multiplication, I will be getting the output of my 4 samples. Tell me, am I clear? Is this thing clear? So let's see. I'll write here, sum is equal to, that is the weighted sum, np dot matrix of x comma weights. See, that's the output we got here. Okay, now we have to add a bias value also. So let's add the bias value as 0.02. This is my bias value. So basically what we have done basically this operation. Now we have to apply the activation function and we have to get our final output. So first of all, please complete, all of you. Then I will move further. Please do it. Okay, fine. Now, now we have to create. We have to pass this output to the activation function. So let's create a function for this activation. So df, let's give the name as act, that is activation function of x. So what it should return, let's give the full name. It should return 1 divided by 1 plus np dot exponent, that is e to the power minus x. This it should return. This is only what? This is the formula for what? Sigmoid. See, now let's print the final output. So let's give it in a same line. That will be more better. Y pred, that is the predicted output, is equal to activation of sum. So if I execute and print the Y pred value, see, this is what we are getting between 0 to 1. So tell me, if you consider the threshold value as 0.5, that means what the value greater than 0.5 is considered as 1, and the value less than 0.5 will be considered as 0. So in that case, what is the output we got here in terms of 0 and 1? Tell me, what is the output we are getting here in terms of 0 and 1? All 1. Actually, we are getting what? Everywhere we got 1. You can round this and you can check. See, we are getting 1, 1, 1, 1. But what we were expecting? We were expecting 0, 0, 1, 1. That means we are not getting the output according to our expectation. So we have to apply the gradient descent and back propagation and reduce the error, because there is an error. That's why I am getting the wrong prediction. Okay. So please, all of you, do these two parts. Then I'll tell you how to calculate error and how to apply gradient descent to it.
So please share collab link.
Okay.
Not shared.
I have shared. I think you have not noticed. I'll share it right now. Get it. Yeah, you can apply other activation function also, but it depends on the output that you want to expect. Okay, I'll explain you after completing this in the slide that what are the other activation function that you can use for different problem statement. Okay. Okay, so I hope everybody has completed now. So now what we are going to do, we have to apply the gradient descent. So first of all, let's calculate the error. So error is equal to actual is what? Y minus Y pred. So this is my error, which we have to move it near about 0. We have to make it near about 0. This is the error. So let's apply gradient descent. So for gradient descent, we will make a function def. Let's take the name as grad, and here I will take x a comma x. Now return. Now what is the formula of gradient descent? Alpha into dy by dx. So your alpha will be your a, where we will pass the error, multiplied by derivative of the activation function. So the activation function we have used is sigmoid. So do anybody know what is the derivative of sigmoid function? Yeah. Derivative of sigmoid, anybody? Yeah. At least you can give this answer. This thing you should know. Anybody? X multiplied by x into, yeah. No one? Okay, I think no one knows this. Okay, I'll tell you. X into 1 minus x. This is the derivative of sigmoid. X multiplied by 1 minus x. Now, so adjustment is equal to, adjustment means how much weight we have to adjust So adjustment is equal to grad of, in place of A, we will pass error, and in place of X, we will pass the Y pred value. Now, so this is your gradient descent. Okay. Now let's apply the back propagation. So weights equal to weights plus, I'm changing the previous weight, plus np dot product of x comma adjustments. Now see, if I execute this, it will give me the error. Just a minute. See, saves 4, 3 and 4, 1 not aligned. That means we cannot do the dot multiplication of these two matrices. 3, 4 can be multiplied with 4, 1 because number of columns should be equal to number of rows. You must be knowing this. So here I will do x dot capital T. That means we are transposing this x. Now after applying this, if I print the error now, so this is my error right now. You can see there is no change. It's completely same. But if I execute this code again, can you see some change in the error? Just see here and here. It got reduced. Tell me. If I execute again it got reduced. See. So every time I am running, the error is reducing. So how can we make this error to near about 0? How can we make it? Yeah. How can we make? Yes. Execute the code in the loop. Correct. So for I in range, let's execute this 1500 times. More and more you train, more and more accuracy will be the model. But sometimes more training can also affect the model also. But right now I'm taking here 1500 times and executing all the codes inside the loop. Done. Now let's print the error. Can you see? It got near about 0, got reduced to near about 0. And if I print y pred now tell me, if I consider the threshold value, what is the final output right now? What's the output here? Is it not 0011? And this is only we were expecting, right? So my error got solved. My problem got solved. Okay. So please complete this. Then I'll tell you one more thing in this. Please complete. I'm just coming in a minute. Complete this. Okay. Is there a technique to know how many times? No, it's a trial and error. Yes, it's a trial and error. There's no technique. That depends on you. Suppose you have done 500 times and you are getting a high error, then execute again 500 times. That's a hit and try. Okay. Is it done? Okay. Now see, if I print the value of weight now, if I print the value of weight, can you see that my initial weight was something else? Now this is my final and new weight. So which input is having a maximum weight here? Tell me which input? Which input is having a maximum weight here? Yeah. Input 1, na? See here. Which one is greater? Input 1. So let's see why we got the maximum input, maximum weight for input 1. If you see the sample, input 1 is 0, the output is 0. Input 1 is 0, the output is 0. Input 1 is 1, the output is 1. 3, input 1 is 1, the output is 1. So can we say that the output is depending on input 1? That is why it is having more weight for the input 1. If my output depends more on input 2, then the weight of input 2 will be more. Am I clear? All of you, please tell me. Is this thing clear? Now see, if I change my output here, just suppose I am giving here 1, 0, 1, 0. Now tell me, here my output is depending on which input? 2. Now let's run all the codes and check. Can you see now? The weight of input 2 is maximum. That's how it works. Okay. So this is how you have to create a neural network from scratch. So I hope now the concept of neural network is clear to everyone. All the small doubts and everything, if you have, it's now clear. Initial weight, I told you, you can take any weight. You can take 2, 3, 4. Doesn't matter. You can take any random weight. There is no rule for that. Okay. So this is the completion of this. Now let me tell you about one more thing. Let me take the overview of this slide. I'll tell you some more things in this. This is what I explained. This is a formula. I already explained this. Okay. Multiple perceptron network, that is a multi-layer. This thing also I explained. Now let me talk about some more activation function that you can use for different kinds of problem statement. Like the first one is step function, sigmoid, hyperbolic tangent, rectified linear unit, and there are so many more. I'm just taking consider 3, 4 here. So step function you can use in that case where you want the output either 0 or 1. So it will simply give 0 and 1. It will not give in decimal. It will not give the value between 0 to 1. It will simply give 0 to 1. So if we have a negative values also, then we can consider this. Here negative values will be considered as 0 and positive value will be considered as 1. Okay. If I talk about sigmoid, here the range of value will be between 0 to 1. Between 0 to 1. And the threshold value that we take is 0.5. This thing already we have covered. Okay. Third one is the tangent function. We use tangent function in that kind of problem statement where you are getting the output between the range -1 to 1. Where the output is between -1 to 1. So this is it looks like a sigmoid only. But here the range of the output is between -1 to 1, not between 0 to 1. Okay. So these are the formulas. You can use any of these to get the output between -1 to 1. ReLU, that stands for rectified linear unit function. Here the output is between 0 to infinity actually. If the output is negative, it will be considered as 0. And if the output is positive, it will be considered as that number only. That means out of 0 and x, it will give the output which is greater. If x is greater than 0, x will be the output. If 0 is greater than x, then 0 will be the output. So this is the function ReLU, rectified linear unit. So according to your activation, according to your output, you can decide the activation function and you can apply. Cost function, that's an error that we have already discussed. Difference between the actual and the predicted values. That means it calculates the error. And this is a formula, summation of y minus a ka whole square divided by n. This is actually called mean square error. To calculate the overall error, we use this. But in case of complex problem statement, we don't use this formula because it slows down the learning of a neural network. So in that case, we use cross entropy. Okay, we use cross entropy, and the formula for the cross entropy is -1 divided by n multiplied by summation of I equal to 0 to n into y into log of a plus 1 minus y into log of 1 minus a. where y is your actual value and a is your predicted values. Okay. Gradient descent, I already explained. You can see the weights values are changed till we get the least cost. Cost means error. This is your diagram for the gradient descent. Optimization algorithm for finding the minimum value of a function to reduce the cost. Reduce the cost means reduce the error. So this is my initial weight here I have taken, and initially we are changing till we get the least error. Afterward, if I'll increase the weight, the error will increase. That's why it got stopped here only. And back propagation already explained. Revision of weights, changing of weight is known as back propagation. So this was all about the artificial neural network. So I hope everybody is clear for this. Yeah. So in the next session, we will be doing about convolutional neural network. And there is one important thing that you have to prepare for the tomorrow's practical. I'll tell you now what is that thing. I'm going to share one zip file which contains near about 2500 samples of dog and cat image on which we will apply the CNN. So this is approximately, I guess, 54 MB of file. So if I have to do the practical tomorrow, maybe it will be difficult for you to upload this file that time. So what you have to do is, I will share the link of this zip file with you right now. Download this file today in your system and upload this file to your Google Drive. We will directly read this file from the Google Drive. You don't have to extract and upload. Directly you have to upload the zip file. Simply download and upload to your Google Drive. And you have to upload it to this folder, my drive folder. Here you have to upload. Am I clear? Please tell me. If you don't upload, maybe you will not be able to do the practical tomorrow if you want to do, because this will be required tomorrow. Yes,
Umang
yes, sir.
sir, I am
Yes,
including you in the group. You please post it, that file in the group, so all participants will get it and they upload
Okay.
it in the
Okay,
drive.
sir. After some time, I'll post that link in the group also. Sure, sir.
Yeah, sir. Yeah.
Okay. Right now, I'm giving on the chat. You can take it from the chat. And after some time, I will post this link in the group also. You can take the link from the group also. Okay. And today's coding file, I will be uploading. Just a minute.
So today's presentation also, please.
Okay. I'll upload the PDF also. This you are asking about this one, na? Okay.
We are giving all the videos, sir. No problem. In case if you have any presentation, so please provide me, or you drop in our group also, sir. No problem.
Okay. So right now I will upload it to the Google Drive and I'll share the link of that file.
Right.
Okay, I have uploaded the PPT also, and this is the today's coding file. So I'm sharing this link also. I'll share in the group also, but I'm sharing this on the chat right now. Yeah. Okay. So now, if you have any doubt, regarding whatever we have discussed, you can ask me now. I have shared the link of this drive in the group. Yes, both the drive link I have shared in the group. You can take it from the group also. Yeah, so I hope you all understood today's session and it was useful for you. Now, any doubt if you are having, you can ask me. And tomorrow's session, we'll be discussing about the convolutional neural network. And we will be using the library tomorrow because we cannot do it from scratch because that will be a very complex problem statement. Okay. Yeah, thank you so much for your feedback.
Okay. Sir, can we take one snap in case all the participants will have camera?
Yes, sir. Why not?
In case is it possible? So, dear all participants, please, if you have camera, please turn on. We will take one snap. No problem.
Just a minute. I will open my camera.
Sir, you just de-share your file, sir.
Reshare my files.
No. शेयरिंग निकाल लीजिए सिर्फ.
अच्छा हाँ ओके ओके.
हाँ यानी वो सब इसमें आ जाएगा.
Okay. Yes. Where is the camera? Okay. Yes.
All the participants, please turn on camera, please. If you have camera, please turn on. No problem. Just for 1 minute only. नाही नाही माझ्याकडे तिथे मी डायरेक्ट नंतर घेईन. नाही नंतर घेईन. नरेंद्र लोखंडे, पल्लवी सालुंके, पीटर, प्रताप सिंह, कुमार, कविता, प्लीज टर्न ऑन सर कॅमेरा. हरीश, डॉक्टर पार्था मिश्रा, दीपा माहेश्वरी, गणेश कुमार, हरीश. ओके. आई थिंक इट ज्यादा नहीं है पार्टिसिपेंट. ठीक है. ओके, नो प्रॉब्लम. थैंक यू सर.
Done, sir.
Yes, sir. Done.
Okay, sir.
Right.
Okay, so bye all of you, and we'll
Bye.
meet tomorrow. Take care and have a nice day. Okay, bye, sir. Take
Bye,
care.
sir. Thank you, sir.
Bye.
Okay.